Hi, so we're going to talk about the algorithm to solve the max flow problem, but it's going to be split into two parts. We're going to talk about part one in this video. So before we talk about the actual algorithm, there's one more concept we have to talk about. It's called the residual capacity. Residual capacity is just capacity, but it's the remaining capacity of an edge after some flow has already been sent through it. So if you look at this example here, the capacity of this edge is 5. Flow of 3 has already been sent through it. So what's the remaining capacity of this edge? Well, it's 5 minus 2, right? I'm sorry, 5 minus 3, which equals to 2, which basically means we can send another 2 units of materials through it without violating the capacity constraint, right? So mathematically, it's exactly what you would expect. A residual capacity is just the capacity minus all the existing flows on that edge. So with that, we can take a first pass at the Ford-Fulkerson algorithm. Is one of what's called a greedy algorithm. And what a greedy algorithm is that it seeks solution that is only locally optimal. So what locally optimal means is that, for example, most corporations nowadays, they are focused on maximizing the quarterly profit, right? That's what the investors always ask for, make as much money as possible, but for this quarter, right? So they don't necessarily care that if they are maximizing the quarter for the next year or the next decade. They're focused on optimizing for from quarter to quarter. So quarter to quarter is fairly local, right? It's a fairly short period of time. So that is in contrast to a company that might have a long-term vision for the next year, the next decade, the next 20, 30 years. So what that company might do is that instead of maximizing the profit for the next quarter, they want to maximize the profit for the next 10 years. Right? So that's not focused on something that's just short-term optimal, but long-term or more globally optimal. So hopefully that makes sense. But anyway, let's get back to the Ford-Fulkerson algorithm. So the algorithm runs in a loop, just like most algorithms. And what it's doing is that it tries to see if there is any path with available capacity from the source and the sink. And as long as there is such a path, then it will figure out, okay, what is the maximum allowable flow through this path? Well, the maximum allowable flow through this path would be the minimum capacity of all the edges along this path, right? And then and then it will send that flow through the path. Now, because it just sent a flow through the path, it would have to reduce the capacity or the residual capacity of all the edges along that path by the flow that it just sent through, right? That kind of makes sense. And it will loop through this process as long as there is still a path. And that's it. So um, this is greedy in the sense that there's nothing here that says we are looking for the maximum possible flow, right? It just let's just get some path and let's send whatever we can send through it. So that's why, I mean, if you look at this, it just seems to be only locally optimal, and that's actually true for this pass of the algorithm. And it's not the complete algorithm, but this is the basic idea. So let's see how it works with an example. So this is the simple network that we've been looking at. So in this network, A is the source and D is the sink. So let's see how we find the maximum flow from A to B, D. Okay, so the algorithm says First, let's pick a path from the source A to the sink. So we'll pick this one. This is the path we pick. And then let's find out what is the maximum flow we can send through this. So the maximum flow is, well, the minimum capacity along this path is 2. So that means we can only send a flow of 2 through this path, right? Because if we send 3, then flow of 3 would not be able to go through this edge with the capacity of only 2. So anyway, so we send that flow through, and this is what is being shown on this graph here. So that, now we have 2 over 3. 2 is the flow, 3 is the capacity. And then we have, 2 over 2. 2 is the flow, capacity is 2. So this graph here it shows, the number here shows all the residual capacities of all the edges. And then this graph here kind of show you what are the current flows through all the edges. Okay, now that we send some flow through the network, we have to update the residual capacities, and that's how it turns out to be. If you look at this edge, we send a flow of 2 through a pipe, an edge with capacity of 3, so the residual capacity is just 1 here. And then for this edge, we use up all the capacity, so the residual capacity is 0 now. Okay, so this is the updated residual capacities, and then we'll now repeat the algorithm that we want to pick another path through the network from A to D. So this time we pick this path, and again we look at the minimum capacity along the path or the maximum allowable flow, and that would be again 2, right? Well, you should know why. So, and then we record that here. So we send a flow of 2 on this edge and a flow of 2 on this edge. Okay, now that we send more flows through the network, we should again update its residual capacity. So the edge here, all its capacity has been used up, so it becomes 0, and this edge it still have 1 remaining capacity, so that's why it's 1. So finally, we have to, now that we have this residual capacity network, and we have to pick another path, see if there's another path through it. And there still is. So from A to B, B to C, and then C to D. So, and the minimum capacity along this path is 1. Right? So, and that's how much flow we can send through this path, and that's what we end up with. So through this path, we use a capacity of, we send a flow of 1. Now, we also send a flow of 1 through this edge here. Previously, we already sent a flow of 2, so the total flow that goes through the edge is now 2 plus 1, and that would be 3. And then the same thing for this edge. Previously, we have a flow of 2. We send an additional flow of 1. And the total flow through this edge is 3. So now we have to again figure out what the residual capacity is. I run out of room, so I draw the resulting or the residual capacity network here. You look at all these edges, all of the capacity have been used up, so that's why they're all 0. Now this edge still have residual capacity of 4, but it's not very useful. We can no longer find a path with available capacity from A to B. So in this case, we are done, and the last flow that represents the maximum flow from A to D, and that matches what we saw previously. We said the maximum flow is 5. So there's total of flow of 5 coming out from the source, and total of flow of 5 going into the sink. Okay, so hopefully you have an idea of how the algorithm works now. So it's your turn to try to run the algorithm through this flow network. Now, this flow network is actually an example from your readings. The source is S and the sink is T. Uh, so and this is actually the max flow through the network. So run through the algorithm, and hopefully you will get this max flow. If you don't, it's actually okay because this is only the first pass over this algorithm. So, okay, hopefully you've done the exercise and moving on. So this is the algorithm again. Now, one part of the algorithm we should really think about is it picks a path, which means it really can pick a random path to send the flow through, right? So the question that you might have in your mind then is, if it's just a random path, how do we guarantee that it will lead to the optimal solution, which is the maximum possible flow from a source to a sink in the network? And the answer is there's no guarantee that it can do that. And we will see an example of that. So here's the same network again. Now, we know as a previous demonstration, the first path we pick is through from A to B and then B to D. Now, what if we pick a different path as the first step? That we pick this path from A to B, B to C, and then C to D. Now, in that case, the minimum capacity along this path would be 3. So we are to send a flow of 3 through this path. And if you look at the residual capacity, after we send this flow through, the residual capacity of this edge is 0. Residual capacity of this edge would be 2, 5 minus 3. And then again, the residual capacity of this path now is 0. Now, if you look at this residual capacity graph, you actually can no longer find another path from A to D. It's done for. And so basically the maximum flow then would be just 3. And we know that is not the optimal, or that is not the maximum flow. So this is a demonstration of there is something missing in this algorithm. And to see this for yourself, in the previous exercise, if you actually were able to find the maximum max flow through this network, then I'm going to ask you to try again. But this time, when you pick a path, pick the path from S to A, and then A to D, and then D to T. So after you do this, work out the residual capacity network and see if you can still arrive at the max flow in this form.